Alrighty, guys. Here we go with section 1.4 video. This one should be shorter than the last one. So here we go with 1.4 properties of real numbers. After this lesson, I will be able to identify and use properties of real numbers. So let's take a look at our getting ready here. Tell whether each pair of expressions is equal by completing each statement with either an equal sign or a not equal sign, and explain your answers. So if we take a look here at some of these, 34 plus 12, is that the same as 12 plus 34? Well, 34 plus 12 is 46. Over here, you would also get 46, because 12 plus 34 is also 46. So that one is, in fact, true. Or the left side is equal to the right side. As I jump to the next one, 100 minus 1 is 99, but 1 minus 100 is negative 99, so this one would be a not equal. Here in number 3, 0 plus 180, well, 0 plus 180 is just 180, which is the same as this right side, so that would be an equal sign. So that one also works. Here, this is a tricky one here. When you take 18 and you divide it by 1 over 18, actually remember when you divide by a fraction, you take the fraction and flip it and then multiply. So this left side would actually wind up being 18 times 18, which is not 1. So that one does not work. 45 minus 1 is 44, which is obviously not the same as 45. When I get down here to the bottom, 6 times 1/6 is in fact equal to 1. 6 times 1/6 is 1. That is obviously the same as 1. So that one also works. So what we see here is some mathematical numerical relationships that are always true for real numbers. So let's take a look at those a little bit deeper. Relationships that are always true for real numbers are called properties, which are rules used to rewrite and compare expressions. So here are some of our properties. Two algebraic expressions are equivalent expressions if they have the same value for all values of the variable. So regardless of what number I put in for a certain variable, I would always get the same number on both sides of my expression. So the following properties show expressions that are equivalent for all numbers. So let's take a look. The first one is called the commutative property, and this one works for addition and multiplication. What it means is that changing the order of the addends, the things that you add together, does not change the sum. Also, changing the order of the factors, things that you multiply, does not change the product. Product is the answer you get from a multiplication problem. So let's take a look at the symbols. Algebraically, we would say A plus B is the same as B plus A. All right, you want some numbers as an example? Well, 18 plus 54 would be 72. And that is obviously the same as 54 plus 18. So when I add, it doesn't matter what order I add them in. That's what they're telling me here. All right, when I multiply, A times B is the same as B times A. All right, so let's look at some numbers. So 12 times 2 is 24. That's the same as I would get if I multiplied 2 times 12. So when we multiply, the order doesn't matter. That's what the commutative properties tell me. Keep in mind, this only works for addition and multiplication. It does not work for subtraction or division. If I were to take 18 minus 54, I would get negative 36. But if I take 54 minus 18, I would get positive 36. So it does not work there. If I would take 12 divided by 2, I would get 6. If I take 2 divided by 12, now I get 1/6. So it doesn't work for addition, for subtraction or division. All right, only addition and multiplication. All right, next property is called the associative property. Associative property deals with the grouping. So changing the grouping of the things I add together does not change the sum. Changing the groupings of the things I'm multiplying does not change the product. And what I always learned this was an association is a group of people. So the associative property deals with how things are grouped together. In math, you know things are being grouped when you see a parenthesis or a bracket or a brace. Okay? So when I look for associative property, I'm looking for things that have moved the parentheses or the brackets or the braces. For example, in parentheses A plus B plus C, well, that's the same as if I added A plus B plus C. Keep in mind you would add these together first and then add the C. You would get the same answer if you added B plus C first and then added the A in there. If you want to look at some numbers, 23 plus 9, that's 32, plus 4 is 36. It's the same thing you would get here. If you added 9 and 4 and got 13, plus 23, you would still get 36. Okay? So we just grouped them differently, and that changed how which part I would do first, but in the end it did not change the final result. It also works with multiplication. A times B times C is the same as A times B times C. So with some numbers, 7 times 8 times 9, I'd have 72 times 9. 56 times 9. Over here I would have 72 times 7, and I would get the same answer for both. Okay? So I think that'll make sense for you. If you want some smaller numbers, just to illustrate it for you, 1 times 2 is 2, times 3 is 6. That's the same thing you would get if you took 1 times 2 times 3. 2 times 3 would be 6, times 1 would be 6. So the left and the right are obviously the same. Again, keep in mind, this only works for addition and multiplication. It will not work for subtraction or division. All right, moving forward, those are the big two. So there's some other ones that kind of make sense as we look at them. So the identity property. Identity is, if your identity is who you are. Okay, so as you think of identity property of addition, well, the sum of any number and 0 is just the number. Okay, and the product of any number and 1 is just the original number. So with some symbols, you'd see it as A plus 0 is just A. All right, with some numbers, a number plus 0, like 4.2 plus 0, just gives me 4.2. All right, so whatever I am, and I add 0, I'm just going to still be whatever I am. Multiplication property, I do that with 1. So any number times 1 is just that same number. So like 67 times 1 is just 67. So those are pretty easy identity properties. All right. The 0 property of multiplication, well, when we first learned multiplication, we learned this property. We just didn't, probably have a real technical name for it. The product of any number and 0 is 0. So anything you multiply by 0, your answer is going to be 0. That's called the 0 property of multiplication. Take a number, 4. Multiply by 0, you get 0. You could take negative 8.6. Multiply by 0, you're still going to get 0. So anything times 0 is 0. That's the 0 property of multiplication. All right? And then I have the multiplication property of negative 1. So if I take any number and I multiply it by negative 1, I just get the opposite of whatever that number was. So any number times negative 1 gives me the opposite of what that number was. So if I took 4 times negative 1, I would just get negative 4. If I took negative 8 times negative 1, I would just get positive 8. All right? So anytime I multiply by negative 1, I always just get the opposite of the number that I started with. All right? So those are our big properties. Let's take a look at some examples, and our job is to find out what property is illustrated by each statement. Okay, so here in letter A, they're taking a number and they're multiplying it by 0, and they're getting 0. All right? So that would be my 0 property of multiplication. Any number times 0 is just 0. If you look at B, notice what's going on here. There's a grouping symbol around here. They have not changed the order around. Notice y plus 2.5 plus 28. This is still y plus 2.5 plus 28. The only thing that's changed is the grouping symbol, the parentheses. Okay? So what you see here is that they changed the grouping symbol. Remember, grouping is the association. All right? So that's the associative property, and since I'm doing addition, associative property of addition. Here, in letter C, I'm taking something and I'm adding 0 to it, and I wind up with the thing that it originally was. So I have something, I add 0, I wind up with the same thing I started with. That's my identity property of addition. And here, 1 plus 2, well, that's the same as 2 plus 1. So we flipped around the order of these things. Remember, the order deals with commutative property. So this would be the commutative property of addition. All right. So there's a couple examples here in the Got It. Let's see what you do with those. So go ahead and take a second. Please make sure you do those so we can know if you're getting it. All right. So whenever you're ready, unpause the video and come on back. So here we go. Problem 2, using properties for mental calculation. So a movie ticket costs $7.75, a drink costs $2.40, and popcorn costs $1.25. That would be great if the popcorn only costs $1.25, wouldn't it? What is the total cost for a ticket, a drink, and the popcorn? All right, so it's an easy question. The total, I just have to add them all up. So I'm thinking I got to add $7.75, $2.40, and $1.25. But it might be easiest if you were using it in your head, no calculator, to add the $7.75 and the $1.25 together first, because it's easy to add a 75 cents and a 25 cents. So this piece here, if I did that first, I would wind up with 9. So then I would just have $2.40 plus 9, which is $11.40. That's probably easier than adding these two together and then adding the $1.25 to it. You'd still get the same answer, however. All right. Question B. A can holds 3 tennis balls. A box holds 4 cans. And a case holds 6 boxes. How many tennis balls are there in 10? It should say 10 cases. All right. So it should say how many tennis balls are in 10 cases. All right. Well, if there's 3 balls in a can, and there's 4 cans in a box, and there's 6 boxes in a case, and there's 10 cases, well, then I would just multiply them all together. All right, might be easier, find numbers that you're good at multiplying. So perhaps it's easiest to multiply the 4 and the 6 and get a 24, and then multiply that by 3, nice small number, 72, then multiply it by the 10 and get a 720. So you can see that you can use these, change the order around to make your life a little bit easier. All right, that would be the commutative property of multiplication, just changing that order around. All right, problem number 3, writing equivalent expressions. So use these properties to help you simplify the expressions. So 5 times 3n, well, remember what 3n means. 3n means 3 times n. So that would just be 5 times 3, which is 15, times n, which is just 15n. Over here, I got to add 4 plus 7b. Well, I can't because they're not like terms. But then I'm going to add 8 to it later on. So probably easier to just see it as 7b plus the 4 plus the 8. Well, the 4 plus the 8 is just 12. So 7b plus 12. If you had 12 plus 7b, that would also be the same. Because again, that's just flipping the order around. There's your commutative property of addition. Over here, 6xy, well, that means 6 times x times y, and then that whole thing divided by y. So if we break that apart a little bit, the top would be 6x times y, the bottom would just be a 1 times a y, and then it's easy to see, well, 6x times y, 1 times y, y over y just becomes 1. Any number divided by itself is just 1. 6x divided by 1 is just 6x. So this whole thing would just be equal to 6x. In D, well, I have a 3/10 times a 1/2 times an x. So just group it that way. 3 over 10 times 1 over 2 would be 3 over 20 times x. Well, 3 over 20 times x is just 3 over 20x. All right? So you probably have used these properties. You probably just didn't even know the names to them. Or perhaps you already did. So we got some Got It questions, so give them a shot so we can see how you're doing. Pause it. When you're ready to go ahead, unpause. All right, so problem 3, reasoning and properties were used to show that 2 expressions are equivalent. This is an example of deductive reasoning. So deductive reasoning is the process of reasoning logically from given facts to a conclusion. All right, so just kind of working through the problem using your properties. To show that a statement is not true, all we have to do is find an example for which it doesn't work. All right. An example showing that a statement is false is called a counterexample. And we only need one of those to prove that a statement is false. So let's take a look. Here in problem 4, it says use deductive reasoning and counterexamples. Is the statement true or false? If it is false, give a counterexample. So for all real numbers, a and b, a times b equals b plus a. Well, let's think about that. So if we take two numbers, let's say 5 and 3. So if we took 5 for a and 3 for b, they're telling me that 5 times 3 should be the same as 3 plus 5. Well, that's certainly not true. Okay? Because 5 times 3 is 15, but 3 plus 5 is 8. So using this example, we can say right away that that's a false statement. All right? This doesn't work. So here's my counterexample. When a is 5 and b is 3, well, it didn't work. I just showed you that it didn't work. Therefore, this must be false. All right? Let's take a look at another one. For all real numbers, a, b, and c, a plus b plus c is the same as b plus a plus c. All right, well, let's go ahead and try to prove it. If you take some numbers and you plug them in, you probably find out that it'll work. All right, and then you have to keep trying and keep trying. Or if you want to prove that it's true, let's use some of our properties. So all we're trying to do is make the left side the same exact thing as the right side. So let's just juggle that around a little bit. Okay, so we just change the order of these. That's my commutative property. I just flip them around. All right, and then I'm just going to rearrange them. So since I can rearrange this grouping symbol with my associative property of addition, well, now look, this left side is the same exact look as the right side. So once those two are the same exact thing, they are equivalent expressions, and therefore we can go woohoo, and we can say that it is in fact true. Okay? Here we go. There's a couple for you to try, so I'd like to see you try. Either use your properties to prove that it's true, or use a counterexample with some numbers to show that it does not work. If you try some numbers and you find that it works a couple times, you're probably going to prove that it's true with your properties. Okay? Best off to not use zeros and not use ones when you try to do these things. All right? So give those a shot, and that's about it. Okay? So I'll see you next time. Peace.